want to talk about polynomial long division. It will allow us to do a division problem that looks like this. X cubed plus 5x squared minus 7x plus 1 divided by x plus 3. Fortunately, the process is much like arithmetic long division. So let me take you back to arithmetic and let's do a long division problem in case it's been a while since you've done one by hand. So let's divide 4,905 by 23. So 23 is our divisor and it goes on the outside. And 4,905 is our dividend and it goes on the inside. Now remember, we look at our divisor, 23, and we see that it doesn't go into 4. So we move on and say, well, it does go into 49, and 23 goes into 49 2 times. So we're going to put a 2 up here. And then our process is to multiply this 2 by 23 and write it down. So let's do that. So 2 times 23 is 46. And at this point, we always subtract. So we have 49 minus 46, which is 3. We bring down our 0, and we repeat the process. 23 goes into 30 1 time, so I'll put a 1 right here. Multiply your 23 by 1 and write it down. And we, again, make sure that we subtract. You don't have to write that minus sign, but I'm just reminding you it's subtraction because that's an issue when you're doing polynomial long division. Sometimes people forget they're subtracting here. So when we subtract, we get a 7. Let's bring down our 5. We'll repeat the process one more time. 23 goes into 75 3 times. So 3 times 23 is 69. And we'll subtract one more time. And we get 6. So we know that our quotient is 213 and our remainder is 6. And depending on the reason for doing our division, we might choose a different version of how to present our answer. In fact, we know 4,905 divided by 23 is 213 and 6 23rds. So we could write it as a mixed number. That's one way we could write our result. Or we might write it this way. We know that 4,905 is equal to the divisor multiplied by the quotient. These two multiplied together with the remainder added in. So we could write it as 23 times 213 plus 6. And again, just depends on what you need the result for. So now let's move to this problem that I have written here on the left, and we're going to use that same process to get the result for this division of polynomials. So I'm going to put my x plus 3 on the outside, and I'm going to put my x cubed plus 5x squared minus 7x plus 1 on the inside, and here we go. Now at this point it feels a little bit different, but mathematically it's equivalent to what we just did, but we have to figure out what we are going to put up here. So here's what we do. We look at the first term in the divisor and just the first term in the dividend, and we decide what we have to multiply by this first term to get this first term. In other words, what do we multiply by x to get x cubed? And the answer is x squared. So I'm going to put an x squared up here. And just like we did when we were doing the arithmetic long division, we now multiply. This x squared gets multiplied by the entire x plus 3. That's how the plus 3 part becomes involved. So x squared times x plus 3. We make sure we distribute. And we have x cubed plus 3x squared. And now we make sure we subtract. I'm going to put parentheses around this. I'm going to put a minus sign here because here's where some of the mistakes are made. So we have x cubed minus x cubed, that's 0. And we should always get a 0 here. If we didn't, that means we chose the wrong expression up here. But now we have 5x squared minus 3x squared, that's 2x squared. We're going to bring down the minus 7x and repeat the process. What do we need to multiply by x to get 2x squared? And that's a 2x. So let's put a plus 2x right here. Now we multiply. 2x is going to be multiplied by x plus 3. So we get 2x squared plus 6x. And once again, we subtract. When we do the subtraction there, we are going to make sure we take care with the signs. We have a negative 7x minus a 6x. So that's negative 13x. We bring down our plus 1, and we continue one more time. What do we need to multiply by this x to get this negative 13x? And that's a negative 13. Multiply those together. We have negative 13x minus 39. We subtract one more time. And we have negative 13 minus negative 13. Again, that first term is gone. We get a 0x. And we have 1 minus negative 39. That's 1 plus 39, or 40. So we have a quotient up here. Right, here's our quotient. And here's our remainder. But as with the arithmetic problem, we have a couple different ways to present our result. It depends on what you're being asked to do this division problem for. We could write the result this way, that x cubed plus 5x squared minus 7x plus 1 divided by x plus 3 is equal to the quotient, x squared plus 2x minus 13, with the remainder over the divisor. So we have plus 40 over x plus 3. So this is equivalent to converting this improper fraction right here to a mixed number. We have this division of polynomials right here, or this fraction written right here, and now it could be written equivalently this way. The other way we could write it is that x cubed plus 5x squared minus 7x plus 1 is equal to the product of the divisor times the quotient. So these two multiplied together. So x plus 3 times x squared plus 2x minus 13, with the remainder added in. Writing the result this way is comparable to the way we wrote the answer over here in the arithmetic problem. Let's do another polynomial long division problem. Here it is. We're going to divide negative 3x cubed plus 8x squared minus 200 by x minus 2. So let's do it. We'll have x minus 2 out here. It's our divisor. And our dividend is negative 3x cubed plus 8x squared. And notice there is no linear term in that dividend. So we need a 0x as a holding place right here. Otherwise, as we work through the problem, things aren't going to line up the way we want. So I will include that 0x, and then I have this minus 200. Now let's practice our process. We're looking at the first term here and the first term here. What do we need to multiply by x to get negative 3x cubed? And the result is negative 3x squared. So let's put that up here, negative 3x squared. Multiply these two together and write it down right here. So we have negative 3x cubed plus 6x squared, and we subtract. As with the previous problem, we expect that first term to go away. We just get a 0x cubed. But now we have 8x squared minus 6x squared, and that's 2x squared. Let's bring down the next term and repeat the process. What do we need to multiply by x to get a 2x squared? That's a 2x. Make sure you include the sign right here. It's a positive 2x. We multiply, and we get 2x squared minus 4x. We subtract, and we get 4x. Bring down our negative 200, and we repeat the process one more time. We look at this x and this 4x, and we see that we need to multiply x by 4 to get 4x, so I want a positive 4 right here. Multiply, and we have 4x minus 8. Subtract, and we have negative 200 plus 8. That's negative 192. Whoop. Negative 192. So here's our quotient, and here's our remainder. So let's see, this time I think I'll present my answer this way. Negative 3x squared plus 2x plus 4 equals the product of the divisor and the quotient. With the remainder added in, and rather than writing plus negative 192, I would just leave it minus 192. And this problem is complete. If you wanted to double check, you could multiply these together. You know how to multiply polynomials together and add in a negative 192, and you should get this polynomial right here. And I have this written incorrectly. This I put, instead of the dividend over here, I have the quotient. Let me erase that. Woo! That wasn't right. So this over here should be negative 3x cubed plus 8x squared minus 200. The nice thing is I was pointing out how if you wanted to double check, you would multiply these together and add in this. That's when I noticed I wasn't writing it correctly. So even just at a glance, I saw that things were looking funny. When you multiply these two together, it definitely should be a third-degree polynomial. Let's do another problem. So this one will be 1 minus x minus 2x cubed plus x to the fourth divided by x squared plus 2x minus 1. And I wanted to point out that the divisor here does not need to be a binomial, nor does it need to be first degree. A second degree trinomial is totally fine. So let's jump in, and we're going to do this problem the same way we did the others. So I have x squared plus 2x minus 1 as my divisor. And the dividend is this polynomial right here. And I'm going to rearrange it. I'm going to write it in standard form with my my term of highest degree written first, and write it in descending powers. So I have x to the fourth minus 2x cubed. Notice there is no x squared term, so I need to put in a plus 0x squared. And then I have a minus x and a plus 1. But even though we don't have a binomial here, we have a trinomial. Our process is still the same. Look at the first term here and our first term here. What do we need to multiply by x squared to get x to the fourth? And the answer is x squared. So I'm going to write an x squared up here. We multiply x squared by x squared plus 2x minus 1, and we write the result right here. So we have x to the fourth plus 2x cubed minus x squared, and we subtract. Be careful with your signs. X to the fourth minus x to the fourth is just 0. Negative 2x cubed minus 2x cubed is negative 4x cubed. 0x squared minus negative x squared is plus 1x squared. And we're going to bring down our next term and repeat the process. What do we need to multiply by x squared to give us a negative 4x cubed? It's a negative 4x. Multiply, and we'll have negative 4x cubed minus 8x squared plus 4x. And subtract. So we have 9x squared minus 5x. You must take care with those signs. Bring down our positive 1, and here we go again. What do we multiply by x squared to get 9x squared? That is a 9. So I put a plus 9 right here. Multiply, and we have 9x squared plus 18x minus 9. And we subtract. So our remainder is negative 23x plus 10. Now at this point I want to point out that we have our remainder because the degree here is smaller than the degree here. We won't get down to just a constant here if we have a second degree term, or we might not. As soon as this expression here has a degree that is smaller than your divisor, the problem is finished. You have your quotient and you have your remainder. So let me write this one. Let's see if I can write this one out correctly. I have x to the 4th minus 2x cubed minus x plus 1. And notice I still rewrote it in standard form rather than writing it this way. Equals x squared plus 2x minus 1 times x squared minus 4x plus 9. So again, it's our divisor multiplied by our quotient. And now we need to add in our remainder. Plus negative 23x plus 10. And I have it complete. Let's do this last example. It will be x to the 5th minus 5 divided by x squared minus 2. So let's set it up. We have x squared minus 2 as our divisor. Now you'll notice I didn't put in a 0x, although you could write this as x squared plus 0x minus 2 as the divisor. You don't need to, and I'll show you why in just a moment. But for the dividend, I do need to include any missing terms. So I have x to the 5th. I don't have an x to the 4th, so I need to include a 0x to the 4th and a 0x to the 3rd. 0x squared, a 0x, and then I have minus 5. And let's begin. What do we need to multiply by x squared to get x to the 5th? And by the way, if you don't see that, you can come over to your scratch paper and divide. You can look at x to the 5th, divide it by x squared, and you'll see it's x cubed, and that's what you'll put up as part of the quotient. So you can just do a little division on scratch paper and figure out what goes up as part of your quotient. So it's going to be an x cubed right here. I multiply these two together. I have x cubed times x squared minus 2, and I have x to the 5th minus 2x cubed. And now I'm just going to take care with writing it in the right column. And here's why I don't need a 0x. I can, instead of writing in a 0x to the 4th, which is what I would have if I had a 0x in my divisor, I can simply move the negative 2x cubed over here in the appropriate column, and I don't need any expression with an x to the fourth in it. I just need to make sure I line things up appropriately. So I'm going to do a subtraction. And I have x to the fifth minus x to the fifth. That's 0x to the fifth. We have 0x to the fourth minus technically 0x to the fourth, so there's 0x to the fourth. Again, I don't need to write that. I have 0x cubed plus, right, it's minus a negative, plus 2x cubed. So I have 2x cubed. And we're going to bring down our next term and repeat the process. Now, if you're not sure how many terms to bring down, you could bring down more. Let me show you what happens as we continue. Suppose you didn't know to bring down the next terms. I'm going to look here at my x squared. I'm figuring out what to multiply by x squared to get a 2x cubed, and it is a 2x. So I'm going to put plus 2x right here. So I multiply 2x by x squared minus 2, and I get 2x cubed minus 4x. And at this point, I realize I'm going to have to scoot that 4x over here. That minus 4x needs to be over here. So I see it would have been a little bit nicer if I had brought down that 0x. And you could even bring down that minus 5. You could bring down everything if you're not sure. Now let's do our subtraction. I have 2x cubed minus 2x cubed. That's gone. 0x squared minus nothing is just 0x squared. I have 0x minus negative 4x. That is 4x. And I just have that negative 5 minus 0. That's still negative 5. Or just think of it as bringing down that minus 5. The degree of my expression right here is smaller than the degree here. So our division is done. We have our remainder right here. We have our quotient right here. And if we want to write it out the way we have the previous ones, I would have x to the fifth minus 5 equals the product of the quotient and divisor. So x squared minus 2, that's the divisor first, times my quotient, with the remainder added in. And again, if you felt like doing a double check, you could just multiply these two polynomials together and add in the remainder, and you would see that it equals this dividend right here. I hope you'll go practice doing a few problems using polynomial long division.